We can calculate the empirical formula. How can we get a molecular formula? Well, to get the molecular formula, which is always some whole number multiple of the empirical formula, we need to have the molar mass. The molar mass can be found using a different experiment. There's a couple of different ways to find out what the molar mass is. We're not going to worry about that. So we'll do some problems and we'll just tell you what the molar mass is. So we need to find out what that multiple is. You take the molar mass that you're given, you divide it by the empirical formula molar mass. Look at the empirical formula we just calculated. Calculate the molar mass for that. See how many times that goes into the molar mass. And then multiply all the subscripts by n to get your molecular formula. Let's do an example. The empirical formula for fructose, it's a fruit sugar, is CH2O. There's like a gazillion molecules with the empirical formula CH2O. What's the molecular formula of this? Well, they're giving us the molar mass, the actual molar mass. So what we need to do is we need to take this molar mass and divide it by the mass of the empirical formula. So we have to calculate that. 1 carbon, bless you, plus 2 hydrogens, plus 1 oxygen. That's a 0. What am I doing? 12.01 plus 2 times 1.008 plus 16. 30.026. Grams of that is equal to 1 mole. Now here we see this with units of grams per mole. If 1 mole is 30 grams, then we can also say that the molar mass of this empirical formula is 30.26 grams per mole. I should have 4 sig figs. So we're looking for n, that multiple number. So we're going to take the molar mass of the actual compound, and we're going to divide by the mass of the empirical formula. The units go away. So we have 180.2 divided by 30.026. And this comes out to be 6.00. That means that there are 6 of these in the actual molecule. This is an illustration of the molecule. So the molecular formula, you can think of it this way. There's the empirical formula. We're going to multiply it by 6. So C6H12O6 is the molecular formula for fructose. Any questions? Let's do another one. Butane. Butane contains carbon and hydrogen. It's the fuel in butane lighters. Here's the empirical formula. What's the molecular formula? Here's the molar mass. That's the actual molar mass. We need to find the mass of this empirical formula and see how many times it fits into the actual molar mass. 2 times 12.01 plus 5 times 1.008. 29.06. So N equals the actual molar mass divided by the molar mass of the empirical formula. And that comes out perfectly at 2. That tells me I need to multiply my empirical formula by 2. And you actually have to do the multiplication part. C4H10 is the molecular formula for butane. You're never going to come up with a number here that you have to multiply to get a whole number. If you don't get a whole number here, you did something wrong on the other side. Probably you calculated your empirical formula wrong.